Hello. This is a part of the equilibrium lab that we would normally want you to kind of design an experiment on your own, where you are trying to see the effect of several different stresses on a system at equilibrium. In all six of these test tubes is a solution of cobalt 2 chloride. That cobalt 2 chloride is actually dissolved in alcohol rather than water, so that there's a controlled number of water molecules within the reaction, because water is actually a part of the reaction. So, unlike other systems in which a pure liquid like water would not cause a stress, water is dissolved into alcohol. So, putting water in or taking water out does change its concentration and does change our equilibrium. But this is a unique equilibrium because the color of cobalt changes depending whether it's bound to water molecules or to chloride molecules. Pure cobalt chloride is often pink because of the moisture in the air binding to it and hydrating it. Once we put it in the alcohol, it gets to this purple color. Purple is an intermediate between our pink and our blue, showing that we have at this equilibrium a significant amount of each. We will see color changes as it shifts back and forth when we add or remove a reactant or product to apply a stress. Remember, as we do that, the reaction is shifting to keep the same overall ratio of products to reactants. But if I add any of these things or remove one of them, then that one is out of whack and the other three have to change in order to respond. So the four stressors, or the four possible scenarios, are listed there on your paper. And we're going to do just a very, very simple experiment with this. So the first will be kept as a purple reference solution. And here I am adding solid calcium chloride. So as we put that in there, we see, and I'm going to invert it here a little bit, shake it up and try to get it to dissolve. And what we see is, even though I put in more chloride, it turned blue. So we want to think about what that means in terms of the direction of shift and why it would shift that direction. Our second stress that we will apply is from an acid. In a previous demo, we saw that acids can change the pH, they can change the color of indicators, but the acid can also provide the ions from itself. This is hydrochloric acid. So initially we added a solid. Here, I'm adding aqueous HCl. We're seeing a color change again, but that color change is a little bit different in terms of amount, and hopefully makes sense when we think about how much pure reactant or product we add when we add a solid to dissolve in versus an aqueous solution that contains that same ion. The next stress is, as it said, adding silver nitrate. So we see that nowhere in our reactants or products do we see silver. Nowhere in our reactants or products do we see nitrate. But if we use our solubility rules, we will be able to understand not just our color change, but the appearance of the cloudiness. So what happened here is evidence of a shift as well. And we think about that precipitate formed because the silver ion reacted with and precipitated with one of the species in this reaction. So we got a darker blue, kind of an intermediate blue, a really nice cloudy pink. And here I have some distilled water. We're going to see the effect of that. So most of the time, adding a pure liquid would not impact it. But once again, this is not an aqueous solution. We are actually significantly changing the amount of water molecules there because the liquid was mostly alcohol. So now we have a colorless, not colorless, but a pink, but not cloudy solution that also indicates a shift one direction or the other. So think about which direction the colors prove that we shifted. Think about what we added or removed that would have made it shift that direction.